Look at this security camera footage. Sun Metro Bus Maintenance Facility, El Paso, Texas. Just another Tuesday afternoon. Fluorescent lights humming overhead. The familiar smell of diesel and grease. Mechanics moving between buses performing routine maintenance checks. Hydraulic lifts raising vehicles for undercarriage inspections. The steady rhythm of wrenches turning, compressed air tools hissing, radio chatter in the background. Nothing unusual. Nothing alarming. Just another day maintaining the fleet that keeps El Paso moving. But watch carefully. Upper right corner of the frame. That's Bus 2025. A CNG-powered transit bus sitting on a hydraulic lift. Two workers are positioned near the rear, doing what appears to be routine maintenance. The bus has been elevated maybe 3-4 feet off the ground, standard height for accessing components underneath. And then, in an instant, everything changes. The bus shifts. The front end drops. And before anyone can react, the vehicle crashes down onto the maintenance bay floor. But this wasn't just a mechanical failure. This wasn't just a bus falling off a lift. Because on the roof of that bus, sitting directly above where it impacted, were high-pressure tanks containing compressed natural gas at 3,600 PSI. When those tanks punctured against a nearby control cabinet, the facility didn't just experience an accident, it experienced a catastrophic explosion. The blast tore through the building with devastating force. Part of the roof collapsed inward. Exterior walls buckled and failed. The pressure wave knocked workers to the ground across the entire bay. Those closest to the explosion were engulfed in flames. Security cameras captured it all. Employees scrambling for exits, some knocked unconscious by the blast, others caught in the fireball trying to escape. 2 workers were killed. 11 others injured, some critically. The building sustained millions of dollars in damage and was deemed unsafe to enter for days. But here's what makes this disaster particularly disturbing. This wasn't a crash. This wasn't a vehicle fire. This wasn't operator error or negligence or cutting corners. This was an unexpected failure during routine maintenance, something you never plan for, something that shouldn't happen when everything is done right. And the question that investigators, engineers, and everyone who's watched this footage keeps asking: why did the bus fall from the lift? There was no mechanical issue with the lift itself. No hydraulic failure. No documented equipment malfunction. The lift was functioning normally moments before. The bus was elevated, stable, workers were performing maintenance, and then it just dropped. That's the mystery we're exploring today. And before we're done, you'll understand why this disaster represents something far more terrifying than obvious negligence. It represents the moment when everything was done correctly, and catastrophe happened anyway. February 11th, 2025, 1:30 p.m. Sun Metro Bus Maintenance Facility, El Paso, Texas. The Sun Metro Bus Depot sits near El Paso International Airport, a sprawling maintenance facility responsible for keeping the city's public transit fleet operational. The facility handles everything from routine oil changes to major overhauls, brake systems, electrical diagnostics, engine rebuilds, transmission work. On any given day, a dozen buses might be in various stages of maintenance. Bus 2025 was a compressed natural gas vehicle, part of El Paso's fleet of environmentally cleaner transit buses. CNG buses have become increasingly common in public transportation. They produce fewer emissions than diesel, they're quieter, and natural gas is typically cheaper than petroleum fuels. Many cities across the United States have transitioned significant portions of their fleets to CNG. But CNG systems come with unique engineering challenges and safety considerations. Natural gas, primarily methane, must be compressed to extremely high pressures to store enough fuel for a full day's route. We're talking about 3,600 pounds per square inch, roughly 250 times normal atmospheric pressure. That's similar to the pressure at the bottom of the ocean, 1,800 feet down. To contain this pressure, CNG buses use specialized high-pressure cylinders, typically mounted on the roof to save interior space and provide some protection in the event of a collision. These aren't ordinary fuel tanks. They're composite cylinders, layers of carbon fiber or fiberglass wrapped around a liner, designed to withstand enormous internal pressure while keeping weight manageable. A single CNG bus might have multiple cylinders, each containing several hundred cubic feet of compressed gas. The tanks are engineered with multiple safety features. Pressure relief devices that vent gas if internal pressure exceeds safe limits. Redundant mounting systems to keep them secure even in severe impacts. Materials specifically chosen to resist damage. These systems are tested extensively, subjected to pressure cycling, fire exposure, impact tests. They're designed to be robust, but they're not designed to be punctured by sharp metal edges while still under full pressure. At 1:30 p.m., Bus 2025 was elevated on a hydraulic lift for what appeared to be undercarriage maintenance. The security footage released months later after extensive investigation shows workers moving around the vehicle. 2 employees are visible near the rear of the bus, positioned on or near a ladder, apparently accessing components in that area. The lift was a standard 4-post design, common in heavy vehicle maintenance facilities. 4 hydraulic columns that raise in unison, with adjustable support arms that contact the vehicle's frame at reinforced lift points. When properly positioned, these lifts are stable, designed to hold vehicles weighing tens of thousands of pounds. But something went wrong. At 1 hour 30 minutes and 17 seconds p.m., the front of the bus shifts. It's subtle at first, maybe an inch, maybe less, but once movement begins, it accelerates. The front end drops, the rear rises slightly as the vehicle pivots, and within 2 seconds the entire front section of the bus crashes down onto the maintenance bay floor. The impact is violent. The bus hits at an angle, the front axle slamming into concrete, the chassis torquing from uneven loading. But the real damage isn't to the bus chassis, it's to the CNG cylinders on the roof. As the bus drops, the rooftop-mounted tanks impact a control cabinet, a metal electrical enclosure standing roughly 4 feet high, near where the bus was positioned. The cabinet has sharp corners, rigid construction, and it doesn't give way. The CNG cylinder, descending with thousands of pounds of force behind it, hits the cabinet edge directly. Composite tanks are strong against internal pressure. They're less resilient against external puncture by sharp objects. The cabinet edge penetrates the cylinder wall. What happens next occurs in microseconds but unleashes catastrophic energy. Compressed natural gas at 3,600 PSI doesn't leak slowly. When containment fails, the gas explodes outward with tremendous violence. The rapid decompression is explosive in itself. The pressure differential creates a shock wave. The escaping gas expands instantly, its volume increasing hundreds of times as it returns to atmospheric pressure. The flow rate is measured in pounds per second, creating a roaring jet of methane and air. And methane is flammable. Highly flammable. The explosive range for methane in air is roughly 5% to 15% concentration. Below that, too lean to ignite. Above that, too rich. But in the zone immediately around a rupturing high-pressure tank, you have a perfect mixing of fuel and air, turbulent flow ensuring ideal combustion ratios. Now before we go further, let's address something. I'm sure some of you are already typing "bliv" in the comments. But this wasn't a bliv. A bliv, boiling liquid expanding vapor explosion, occurs when a cylinder containing a liquefied gas under pressure is heated until it catastrophically fails. The liquid boils instantly, expanding to hundreds of times its volume, and the cylinder literally tears itself apart, often launching fragments like missiles. That's not what happened here. This was a puncture rupture of compressed gas, not a thermal failure of liquefied gas. And believe it or not, the workers at Sun Metro were fortunate, if you can use that word for a disaster that killed 2 people, that it was CNG and not something like LPG. LPG, Liquefied petroleum gas or liquefied propane gas, depending on where you're from, is stored as a liquid under moderate pressure. When a cylinder of liquefied gas ruptures, the liquid flashes to vapor instantly, expanding to an even greater volume than compressed gas. The explosion from an LPG rupture in this scenario would have been significantly more powerful. The fireball would have been larger. The pressure wave more destructive. More of the building would have collapsed. More workers would have been killed. CNG explosions are devastating. LPG explosions are apocalyptic. So in that terrible calculus of disaster, CNG was the better fuel to have catastrophically fail. Not that it mattered much to the 2 men who died. The ignition source was never definitively identified, but investigators suspect static electricity from the escaping gas itself. When gases flow at high velocity through jagged openings, they generate electrostatic charges. The gas molecules friction against metal edges. Electrons transfer, charge builds up. Eventually it arcs, a spark. Invisible, momentary. And that's all it takes. At 1 hour 30 minutes and 19 seconds p.m., 2 seconds after the bus began falling, the CNG ignited. The security camera footage shows a brilliant flash, the frame momentarily overexposed as intense light floods the sensors. Then the pressure wave hits. Employees across the maintenance bay are knocked down, some thrown several feet by the blast. The nearest workers simply disappear into the fireball for a fraction of a second before staggering out, clothing ignited, skin already burning. The explosion isn't Hollywood style. No massive mushroom cloud, no slow-motion fireball expanding gracefully. It's a sharp, violent detonation followed immediately by a sustained jet of flame, as the remaining compressed gas continues escaping and burning. The flames shoot horizontally from the punctured cylinder, a blowtorch effect fed by hundreds of cubic feet of methane under pressure. Objects near the blast are thrown across the bay. Metal panels peel away from the bus structure. Glass shatters, the concrete floor cracks from thermal shock, and the building itself begins failing. Roof trusses heated to critical temperatures, structural connections weakening, materials expanding and buckling. Within 10 seconds of the initial fall, parts of the roof collapse inward. Exterior walls, not designed to contain explosion over pressure, blow outward. Dust and debris fill the air, mixing with smoke from burning materials. The fire spreads to other fluids in the bay, hydraulic oil, coolant, grease, creating secondary fires. From the wider security camera angle, you can see employees running. Some help injured co-workers. Others sprint for exits. A few are trapped momentarily by fallen debris or blocked pathways. The confusion is total. Alarms screaming. Visibility near zero from smoke and dust, the ongoing roar of burning gas. 2 employees who were closest to the blast, the ones working near or on the rear of bus 2025, were catastrophically injured. The combination of explosion pressure, thermal pulse, and direct flame contact caused severe trauma and burns. They were conscious initially, attempting to escape, but their injuries were devastating. Emergency services received the first 911 call at 1:31 p.m., approximately 1 minute after the explosion. Multiple callers reported a massive blast at the Sun Metro facility, building collapse, people trapped inside, active fire. The El Paso Fire Department dispatched multiple units. EMS prepared for mass casualty response. First responders arrived to find the maintenance building partially collapsed, heavy smoke pouring from shattered windows and holes in the roof, injured workers scattered across the parking lot being treated by co-workers, and ongoing concerns about additional CNG buses inside the facility that might also rupture if exposed to fire. The 2 most critically injured workers were transported immediately to a specialized burn center out of state. Their injuries exceeded local treatment capabilities. Despite all their best efforts, despite aggressive medical intervention, 1 employee lost their life just 2 days after the explosion. The second fought for nearly a month before passing away on March 10, 2025. Think about that for a moment. Two experienced mechanics showed up for work on a Tuesday morning. They clocked in, grabbed their tools, got their work assignments, routine maintenance on bus 2025. Should have been home by evening. Maybe grabbed dinner with family, watched some TV, went to bed. Instead, one was dead within 48 hours. The other lasted a month in a burn unit, fighting an unwinnable battle against injuries too severe to survive. 11 other workers sustained injuries ranging from minor cuts, bruises, smoke inhalation, to serious burns and blast trauma requiring extended hospitalization. Some will carry permanent scars, both physical and psychological. Some will never return to maintenance work, unable to face the environment that nearly killed them. The facility was declared a hazardous zone. Structural engineers assessed the building and deemed large sections unsafe to enter. The investigation couldn't begin in earnest for days while crews stabilized the structure and ensured no additional gas leaks or explosion risks remained. Once the scene was secured, the question became unavoidable. What caused bus 2025 to fall from the lift? This wasn't a simple equipment failure with an obvious cause. The hydraulic lift showed no signs of mechanical breakdown. The hydraulic fluid levels were normal. The lift cylinders weren't leaking. The electrical controls functioned properly when tested afterward. There was no loss of hydraulic pressure that would cause the lift to descend unexpectedly. The support arms, the pieces that actually contact the vehicle frame and hold it elevated, were found essentially undamaged and still properly locked in the raised position. This rules out a scenario where the arms collapsed or released. So if the lift was working and the supports were locked, how did a 30,000 pound bus just fall off? The most likely explanation, based on analysis of the security footage frame by frame, is that the bus was never properly positioned on the lift to begin with. The support arms contact the vehicle at specific reinforced points on the frame, lift points engineered to handle the vehicle's weight. If the bus is even slightly misaligned during the lift, the supports might initially hold, but any shift in weight distribution could cause the vehicle to slide off the supports. Look at the footage again carefully. Two employees are working near the rear of the bus. They're on or near a ladder, apparently accessing rear components. Could their movement shifting weight toward the rear have created enough force to pivot the bus on the front supports? If the front of the bus was sitting slightly wrong on those supports, not quite centered, any rear loading might tip the balance. It's also possible the bus was already unstable, sitting precariously, and time or vibration from work being performed simply reached a tipping point. Sometimes vehicles settle slightly after being lifted as weight redistributes. A bus that seems stable immediately after lifting might shift microscopically over minutes, and if it's near the edge of the support contact area, that shift could be catastrophic. But here's what makes this deeply unsettling. If positioning error was the cause, this means the disaster resulted from the kind of mistake that happens in maintenance facilities every single day, a vehicle not quite perfectly aligned on a lift. Usually nothing happens. Usually the supports are broad enough and the contact area sufficient that minor positioning errors don't matter. Usually you get away with it. But this time they didn't T. This time, the bus fell. This time, the angle was wrong. This time, the CNG tanks hit that control cabinet at exactly the right or wrong point to puncture. This time, the escaping gas found ignition. This time, 2 men died. And that's the terrifying reality of industrial accidents. They're not always the result of obvious negligence or flagrant safety violations. Sometimes they're the result of small errors that usually have zero consequences. The kind of minor mistakes that happen hundreds of times without incident, until that one time when every variable aligns wrong and catastrophe results. After the investigation ruled the cause as accidental, bus fell, tank punctured, gas ignited, many people asked a different question. Should CNG buses even be maintained on hydraulic lifts? It's a fair question. If a simple fall can turn a maintenance bay into a bomb site, maybe the entire approach needs rethinking. But here's the reality. CNG vehicles have been maintained on lifts for decades across thousands of facilities without major incidents. The Sun Metro explosion wasn't the inevitable result of combining CNG and hydraulic lifts, it was the catastrophic result of multiple unlikely failures happening simultaneously. Think about it. How many times has a bus fallen off a lift at this facility? How many times across all Sun Metro maintenance operations over the years? Probably never, or maybe once or twice in exceptional circumstances. Vehicle falls are extremely rare when proper procedures are followed, and even if a vehicle does fall, the chances of the CNG tanks impacting something sharp enough to puncture them, at exactly the right angle, with enough force, those odds are astronomically low. The tanks are on the roof, away from most obstacles. They're rounded, designed to deflect impacts. For them to puncture, you need a perfect storm of bad positioning, bad angle, and bad luck. That's exactly what happened on February 11th. The bus wasn't just elevated, it was elevated near a control cabinet. It didn't just fall, it fell at an angle that brought the tanks down onto the cabinet's edge. The tanks didn't just impact, they impacted with enough force to breach the composite wall. The escaping gas didn't just leak, it found immediate ignition. Any one of those variables being different, and this disaster doesn't happen. The bus falls but the tanks don't hit anything sharp, minor accident, maybe some injuries from the fall itself, but no explosion. The tanks hit the cabinet but don't puncture, same result. They puncture but the gas doesn't immediately ignite. You have time to evacuate, time to vent the area, time to respond before disaster. But when all the variables align wrong, you get February 11th. The Sun Metro explosion isn't the first CNG vehicle disaster, and it won't be the last. Compressed gas systems, regardless of the specific fuel, carry inherent risks. Here's what most people don't realize. Every CNG vehicle on the road is essentially carrying several bombs. That's not hyperbole. Those cylinders contain enough stored energy that a catastrophic failure is equivalent to a significant explosive device. In 2016, a CNG bus in Sweden exploded at a fueling station when a cylinder ruptured during filling. The blast killed one person and injured several others. The investigation found that the cylinder had been damaged in a previous minor collision, a small dent that compromised the composite structure. Over time, pressure cycling weakened the damaged area until it catastrophically failed. In 2019, a CNG vehicle explosion in China killed multiple people when a taxi's fuel system ruptured after a collision. The taxi was rear-ended at relatively low speed, maybe 30 mph, but the impact was sufficient to damage a fuel line connection. Gas leaked into the vehicle cabin, and when the driver attempted to restart the engine, the electrical system provided ignition. Industrial CNG facilities have their own history of disasters. In 2020, a CNG fueling station in Russia exploded when a compressor malfunction overpressurized a storage tank beyond its rated capacity. The tank ruptured, releasing thousands of cubic feet of compressed methane, which ignited from the compressor's hot surfaces. 3 workers were killed. These aren't freak accidents with defective equipment or obvious negligence, they're the result of CNG's fundamental nature, high-pressure combustible gas that releases massive energy when containment fails. You can engineer safety systems, you can implement rigorous procedures, you can train workers extensively, but you cannot eliminate the inherent danger of storing gas at 3,600 PSI. Following the El Paso explosion, several transit agencies across the United States reviewed their CNG maintenance procedures. Some implemented new policies requiring additional clearance around vehicles elevated on lifts, ensuring no rigid structures are positioned where falling tanks could impact them. Others mandated partial venting of CNG systems before performing certain maintenance tasks, reducing the stored energy available if a rupture occurs. The American Public Transportation Association issued updated guidance on CNG vehicle maintenance, emphasizing the importance of lift positioning protocols, double-checking that support arms are correctly placed at reinforced lift points before raising vehicles. Some facilities now use templates or guides to ensure consistent positioning. Visual inspection requirements, requiring supervisors or second mechanics to visually verify lift positioning before workers begin maintenance under elevated vehicles. Exclusion zones establishing areas around elevated CNG vehicles where tall rigid objects, tool carts, parts cabinets, equipment, cannot be positioned. Pressure monitoring, installing systems that alert maintenance staff if CNG tank pressure is above a certain threshold, potentially indicating a vehicle shouldn't be lifted until partially vented. But here's the uncomfortable truth. None of these measures would have definitively prevented the Sun Metro disaster. Better positioning might have kept the bus from falling. But might isn't certainty. Exclusion zones might have kept the control cabinet away from the impact area. But in a busy maintenance bay, with limited space, that's not always practical. The reality is that some level of risk is inherent in maintaining complex vehicles with high-energy systems. You can reduce that risk. You can manage it, but you cannot eliminate it entirely without fundamentally changing how transit systems operate, and that's not realistic. Let's talk about the two men who died. Though their names haven't been publicly released at the family's request, both were experienced mechanics. One had worked at Sun Metro for over a decade. The other was newer, but had extensive experience with CNG systems from previous employment. They weren't rookies making beginner mistakes. They were professionals who showed up, did their jobs, followed procedures they'd followed hundreds of times before, and they're dead. Not because they were careless, not because they ignored safety rules, not because they took shortcuts or rushed or failed to follow training. They're dead because a bus fell off a lift for reasons that remain unclear, and because the universe aligned variables in exactly the way necessary to turn a maintenance accident into a catastrophic explosion. Think about the psychological impact on the survivors. Imagine being in that maintenance bay, hearing the crash, seeing the explosion, watching your co-workers burn. Imagine running for your life while the building collapses around you. Imagine visiting those two men in the burn unit, knowing they're dying, knowing there's nothing anyone can do. Several of the survivors reportedly left the transit industry entirely. Can you blame them? How do you go back to work in a maintenance facility after watching it explode? How do you climb under an elevated bus again, knowing what can happen? How do you trust that the lift is positioned correctly, that the supports are secure, that the universe won't align against you the way it did against your co-workers? Post-traumatic stress doesn't just affect combat veterans, it affects anyone who experiences sudden, violent, traumatic events. The survivors of the Sun Metro explosion, both the injured and those who escaped unharmed, are dealing with trauma that will last years, maybe lifetimes. We still don't definitively know why Bus 2025 fell from the lift. The investigation concluded accidental cause but didn't identify a specific mechanical failure or procedural violation that explains the fall. The most likely explanation, improper positioning, is really just an educated guess based on how the bus fell and the lack of other obvious causes. This bothers me, and it should bother you, because if we don't know exactly what went wrong, we can't definitively prevent it from happening again. We can implement better procedures, more checks, additional safety measures, but we're essentially guessing at solutions without fully understanding the problem. Maybe the bus was positioned wrong. Maybe there was a subtle mechanical issue with the lift that wasn't detected in post-explosion examination. Maybe the workers shifted the bus inadvertently while performing maintenance. Maybe it was a combination of factors no one anticipated. We don't know. And we don't know is a terrifying answer when two people are dead. The Sun Metro explosion represents a category of disaster that's particularly difficult to prevent the convergence of unlikely failures during routine operations. This wasn't a novel situation. Buses are elevated on lifts constantly. This wasn't experimental technology. CNG systems have been used for decades. This wasn't untrained workers. Everyone involved was experienced and qualified. But disaster happened anyway. Because sometimes, despite doing everything right, variables align in unexpected ways. The bus is positioned slightly wrong. That specific work task shifts weight in a critical direction. The control cabinet happens to be positioned exactly where the falling tank will impact it. The puncture occurs at exactly the right angle to cause immediate catastrophic failure. The escaping gas finds ignition within seconds. Change any one variable, and the outcome is completely different. But when they all align, when the Swiss cheese holes line up perfectly, catastrophe passes straight through every layer of protection. This is the reality of complex systems with multiple energy sources and potential failure modes. You can engineer for safety. You can train for competence. You can implement procedures and protocols. But you cannot account for every possible combination of unlikely events, and that's terrifying. Because it means that sometimes disasters happen not because someone screwed up, but because the universe decided today was the day when everything would go wrong simultaneously. February 11, 2025 started as just another Tuesday at Sun Metro. Workers showed up, clocked in, grabbed their assignments. Bus 2025 needed maintenance. 2 mechanics got the job. They positioned the bus on the lift, raised it, began their work. 2 seconds later, their routine day became a disaster. Within a minute, 2 men were dying from burns that would kill them within days or weeks. 11 others were injured. Millions of dollars in damage. A facility shut down for months. Families destroyed. Lives permanently altered. All because a bus fell off a lift. We don't fully understand why it fell. We don't know if it could have been prevented. We don't know if better procedures or additional safety measures would have made a difference. What we do know is this: complex systems with high energy components carry inherent risks. Those risks can be managed, reduced, controlled, but never eliminated. And sometimes, despite everyone doing their jobs correctly, despite following procedures, despite years of safe operations, disaster happens. The question isn't whether we should continue using CNG vehicles or hydraulic lifts or maintenance facilities. We need public transportation. We need vehicle maintenance. We need these systems to function. The question is, how do we live with the knowledge that sometimes routine operations turn catastrophic for reasons we can't fully explain or prevent? I don't have a good answer to that question. Neither do the investigators. Neither do the safety experts. All we can do is learn what we can from disasters like Sun Metro, implement improvements where possible, and hope that next time, if there is a next time, the variables don't align quite so perfectly for catastrophe. So here's my question for you. After watching this, would you feel comfortable working in a maintenance facility with CNG vehicles? Would you trust that the procedures are sufficient to prevent another Sun Metro? Or would you look at that elevated bus and think about what happened in El Paso? Drop your thoughts in the comments. If these stories fascinate you, subscribe. Thank you for watching.